going through them. I've also made some modifications. We would have had a talk, but the person who would have given that talk is not around, so they sent their apologies. But then I thought, well, then we could just spend the morning where we would have spent looking at version control and Git to recap from yesterday and to catch up, but also to complete something that I thought is really important and we didn't get quite to do it. And also maybe get sort of an enlightenment into another container technology called Singularity. So I've modified the table, and I think I just made some subtle changes. I shared that with Cast, but I need to share this new update with her. That's in regard to time. Just increase that by 30 minutes to sort of allow us a little bit more time, maybe eat into the coffee time, which is not slotted on this timetable, which I should do. But nonetheless, we can work through that. And what I've done is prepared a couple of practicals that we will go through. And then we'll talk a bit in introduction to Git. There are myriad of tutorials for those who are not familiar with Git, and we're just gonna follow one of them, which is the carpentry. So the idea here is not to dive deep into this, but essentially to get the concept and the idea. Yes. What's that? Is it PM? Wow. It should be AM. Yeah, thank you. Yeah, replace PMs with AMs. Oh, all right, that's PM. That's PM. Sorry, yeah, there we go. No, this should be PM. It's after midday because it's 11 AM to 1 PM, right? Unless you want me to use the hours. Oh, this is 10:30 AM. I see what he meant. Yeah, sorry. Yeah, 10:30 AM. Just a few hours. 1 hour, a few minutes. It's 9:23. It's nearly halfway through there. Yeah. So I was just informing us that we're gonna follow one of them, which is the carpentries tutorials, which are really fantastic. And then in the afternoon we can talk a little bit about file organization, and again a recap from what we already will have learned about volumes. And also I thought that would be also a good time to also play around with volumes. Maybe might squeeze in something on Singularity if need be, or if we think that is useful. Yeah. So Tony's just gone through, thank you Tony, sort of the recap from yesterday. And let me see what I prepared. And we had this. I'm just going to, again, just emphasize on the Docker architecture. Let me see whether there's something I had to prepare down here. Yeah. Yeah, I'll come down to this, which I thought were really nice. So yesterday we talked quite about Docker. So for those who are new to this, I just want to emphasize is that we have this platform that allows you and work on your computer. It'll allow you to, pull images, yeah. So, and these images are sort of preset templates of tools that you can make use of, and it will allow you to run containers. So you can run multiple containers from the same image, if you like. So you can have multiple containers, and you can have multiple images. And these containers are lightweight. They allow you to do quite a lot. Install and software if you need to, and run specific analysis in a lightweight way without tampering with your host environment, right? And then we highlighted that we got registries or repositories, if you like, places on the web where people create these images, and your work from this end is to sort of pull. You can pull this, and we'll see how you can do that, and you can get this working. So. As you can imagine, we have this Docker. Maybe before I do that, just go here. So just a few definitions which I thought were important, and just so, again as a part of a recap, again, and to differentiate. So we have Coda, which allows you to create this virtual environment And Coda really works well, with the programs, particularly those that are dependent on Python and run on Python. Okay, so and because of the multiple versions you can have, Coda allows you to quickly install, run, and update packages and their dependencies. And it was created for Python programs, but it can package and distribute software for any language. Okay, so initially it was meant for Python and Python projects. Yeah, and it's just yet another, we saw yesterday, Python is amazing as a language, and I think the ecosystem, the packaging is amazing. And you just got tons of things on how to install software, and it becomes a little bit difficult. So again, this I think was an approach, to have a standard method and an isolated method, so to speak, to allow you to install software. And therefore then quickly got adapted. You can use it with tools that not necessarily created using Python, but the engineering around Coda allows you to do that. And then we come around here to look at Docker, which is a container software, great for developers and teams, and allows you to do this, can experiment and, it provide you an integrated development environment, and provides you with a wide range of community images, software, particularly on Linux, and you can run that in sandboxes, really well isolated, and can do quite a lot of development. And Singularity allows you to, essentially it's like, Docker on steroids. Okay, so it turns out that when you have Docker, it works very well on your environment. But then if you're working on HPCs and you want to take advantage of GPUs, for example, and you want to have full control of your environment, Docker starts to falter. Okay, and Singularity allows you to have full control of your environment, and not just that, but you can launch them across clusters. Okay, and you can have very complicated applications with Singularity. And again, Singularity allows you to create Singularity containers from Docker, but not the other way around. Okay, so again, Docker will run on Mac OS, will run on Windows, will run on Linux. I think Singularity largely runs on Linux. Yeah, I need to check that, but it will run very well on Linux and on HPC environments. Okay, so allowing you to create an app and take advantage of multiple things and quite some complexity. So I thought that I can come that maybe I'll talk a little bit about Docker. But yeah, okay. Yeah. So the one thing that we didn't talk about was that you can launch these containers well and good, but how do you move stuff in and out of your container? Okay, what's the link? Yeah, so you got this sandbox, it's great, it's all virtual. If you realize this, once we run a container and we stop it, it stops with everything in it. So there's no persistence of your data. Often we want to run files, we want to do some piece of work, and we want those results back. So we have to find a way to create some sort of persistence between the Docker container and your file where it's running. And the traditional way of doing it, and this works very well on Linux, is you mount a volume. You mount a file system. So Docker will allow you to mount multiple file systems using the mount command, or even better, using volumes. Okay, so Docker volumes is sort of a way that allows you to persist a volume, and those volumes can run on heterogeneous file system. It can run on NFS, it can run on Scratch, it can run on whatever. Okay, so it's just allowing you, and you can set those volumes, and you can work with multiple teams and persist data in those volumes. Okay, and it's quite easy to run again using the volume command, and that's what we're gonna do. So what I did was I created a quick tutorial here. I hope I got it here. So I got two tutorials. The first one here, I think is a practical one.txt. gonna blow it up a bit. Yeah, and the idea here, let me see, yeah, is to create volumes and to work with those volumes. Okay, so on our command line we can try and do this, but maybe I can walk through this tutorial and what we need to do. So we need to read and write and persist data. So if you run, docker run bash latest, it will pull the container, it will run this command here, echo, and that will persist within that container. And if you quit that, you realize that your container is gone with it. Okay. So let's try to do that. So what I'll try to do here is I'll pull another terminal. So got okay. So I'm in my directory here. I'm just going to pull a few of these, and I got Docker running. So I'll run Docker run bash latest. So just by doing that, so there we go. What it has done is that it's pulled this container here, which I have created, and who's going to tell me what happens when you run something with this? Yeah, it's a way of saying run the next line. Okay. Yeah. So I could have written this command all on one single line. This one here, which is the bash -c and that and that. Okay. So the container echoes back hello. So essentially, maybe I should have someone just tell me what this command is. Is it all visible? Because there's quite a lot going on there. And I assume that we are all sort of advanced users. And this is the beauty of Linux and Unix systems, is just this capacity. Yeah. So we got the first line here, docker run bash latest bash, so that will pull. That's what we've done there, the command, and then the next line just by using that separator there. And then what we're doing is that we call in bash -c, and we call in echo, which just prints to the screen. And what we want to print to the screen is hello. And we are going to redirect this output to this file.txt. Okay, so that file.txt now will contain this, and we simply read from it. Okay, again by using these two double signs ampersands, and therefore we are cutting the file or concatenating the file. Yeah, and therefore file.txt, which contains hello, which is what we put in through bash. Yeah. So this interesting thing is that this all is within the container. Okay. So this all is happening within the container. So the next line here was actually trying to look at what happens when we try to ask Docker to output the file .txt. So I'm going to try and run that. So if I do here, just paste that. See, Docker doesn't know about this file anymore. Okay, so what we are doing here is saying run bash latest bash -c, cut the file that we thought we created over here, but then it doesn't exist. Okay, because it doesn't exist in our environment. It's only within that sorry, Docker environment, and we don't have that file. Okay, so we need to find a way to have communication between our host's file system and the Docker container. Otherwise, it doesn't make sense, isn't it? Okay, so the next task here was to use byte mounts, which is, and I won't go very much into these details, but we can mount file systems and allow us to persist and work with our files. Okay, so the way we do it is that the run command accepts a minus volumes or a minus v command, right? And in here we call this command pwd. Who knows what pwd does? Yeah, print working directory. Okay, and do you know why we are doing the ampersand and putting it? Oh no, the dollar sign and under the brackets. What happens when you do that in Bash? Yes, so yes, yeah, and then the output of this is actually the full path to your working directory. Okay, so essentially, if I run this, I'm just gonna put it in here. If I do pwd, it gives me the full path to my working directory, right? And if I do it's the same. Okay, yeah, so this is a bash subcommand, and what I've done here is that I just called echo and given it this, and therefore it will simply output to my screen. Okay, so let's try and do that. Let's try and persist this now and run this command. So I'm just gonna copy this out. Okay, and now see if I do that, I copy. Oh, what did I do? The test. I think there's something I'm missing here. Bash the test. Assuming that I got everything. Oh, damn it. I'll leave that for now. I guess I got an issue with my file system in Unix, but I'll come back to that, but just to troubleshoot what just happened there. So, but nonetheless, I'm just going to move into the next. So, what we're trying to do here is to mount the file system onto our image, and I think this here doesn't exist, so bash my latest, that won't work. Anyway, I'll sort that out. Yeah. So as I said, you can have Docker manage your mounts in a much better way using volumes. And Docker allows you to create volumes, named volumes, and anonymous volumes. So if you run Docker volume, just, Docker create volume, yeah. Oh, sorry. Docker volume create. Yeah, that's the command. Sorry. Volume create. Okay. What has happened there is that I've created a new volume, and it's been assigned a random number, which is I think cryptographic SHA, just to ensure that you don't have name collisions. Obviously, this is not always what we want, yeah, but this is a nice way for the machine to ensure that it always generates something new, okay, and persistent, and something that is also random. So you end up with these really large file systems, or rather large names. But we could essentially name our volume, yeah. So if I say create and I say my disk, or my disk volume maybe. Okay, now I've created a new volume which I can then access later. And if I want to know what's happening or how many volumes I have several now, I can just use the ls command as we learned. Okay, so you can see my disk volume here, but I also have a number of other anonymous volumes that I created this morning. Okay, so you can see that my disk volume is there, and we can have a look at them a little bit more, and by calling the inspect. So for example, if we say Docker volume inspect, it can provide us a little bit more details. Docker volume inspect my disk. Sorry, my disk. My disk volume. Okay, so it provides me a lot more details about this volume, when it was created, the drivers, the labels, and the mount point on Docker, and the name and the scope. It's sort of a local volume, and then I can use that volume when I'm running Docker container to mount and write and have access to my file system. So the way I want to do that is that I now have sort of a virtual volume which I can share with anyone who is local to my computer and with whom we are sharing sort of a Docker runtime. And I can mount, if I want to do something, I can mount my local file system onto this logical volume, okay, on Docker. And that means that any container that has access to that volume, and because it's running on Docker, any container can have access to that volume, then you can do quite a lot. Yeah? I don't know whether I'm making sense. Yeah? Yes, please.
So there's this, like, there are those files which are inside Docker, and there are those files which are outside Docker. And you mount those folders or files which are outside Docker?
No. So we need to get our definitions correct. So you got Docker, which is a runtime, which is a platform, okay, which allows you to create containers of images. Okay, so you got a container, and if you created, let's say, an Ubuntu image, right? It's sort of a file system. It's an entire operating system. Let me say you want to do something within that environment. Okay, so we have to find a way to communicate between our local host file system, where our files are located, where we want to do something and write output to or with that sandbox environment. Okay, so you can imagine that we've created an environment here. This is where we want, but our data lives here. This is where we don't want to pollute. We have to find a way where we bring whatever is outside here into the sandbox. Okay, so the way we can do that is that we can open gates, communication ways that allow us to access that environment, bring things into the sandbox, do whatever we want here. If we get in output, we also want to persist that output and take it outside. So that's what we are doing. So the way to establish that communication is using volumes. So it turns out that we can create these volumes within the Docker environment, right, if we're talking about volumes. And that also means that anyone else or any other container can access that volume. It can access that communication channel. And as long as it's shared within the host environment, we can persist, move data in and out. And they create a way to share things. Let's say I'm here and Gurdeep is working on her data. We are all sharing the same environment, but she wants to run particular analysis on the same data. And we can share that. Okay? Which would have been difficult if, for example, I'm on Windows platform, she is on CentOS platform, okay, and we all need to work together.